You need to stay up out the streets if you can't take the heat. You need to stay up out the streets if you can't take the heat.
Oh, hey, I didn't see you then. I was just catching up with my reading before we started class. Here are the topics I was reading about and we'll be discussing in class. The z-scores, which is in section 2.1. The 68, 95, 99.7 rule, which is section 2.2. And the standard normal distribution, which is in section 2.2 as well. Observations larger than the mean have a positive z-score, and then a smaller observation has a negative z-score. Now that we have the definition down, we're going to do a few examples up on the board. Alright, the first example we're going to do is there's this test that was taken by two people with the mean of 82 and the standard deviation of 6. First person that took the test was Jeff, and his x value was 92, which is what he got on the test. So we would do 92 minus 82 over 6. Calculate that real quick. Which equals about 1.6 repeating. And then the next one was Mason, and his test score was a 78. So it would be 78 minus 82 over 6, which would be negative 0.6 repeating. The first topic we talked about is the z-score, and the definition of a z-score is if x definition is if x is an observation that has a known mean and a known standard deviation, the standard deviation value of x is z equals x minus mean over standard deviation. A standardized value is often called a z-score, and to standardize a value, you have to subtract the mean of the distribution, then divide by the standard deviation. A z-score tells us how many standard deviations the mean of an observation falls and in what direction.
Alright class, I will be teaching you about the 68, 95, 99.7 rule, which is as follows. In the normal distribution with a mean of 0 and a standard deviation of 1, these three things apply. Approximately 68% of the observations fall within one standard deviation of the mean. 95% of the observations fall within 2 standard deviations. And 99.7% of the observations fall within 3 standard deviations of the mean. This rule only applies to standard normal distributions and is not an exact number, but more of a good approximation. So the first example we are going to do is, or it starts out here, suppose that the distribution is exactly normal with a mean of 6.84 and a standard deviation of 1.55. First question. Sketch a normal density curve and label it. Second question, what percent is less than 3.74? Third question, what percent of the scores are between 5.29 and 9.94?
Okay. First, the mean. plus another standard deviation. Plus another. Now we go back to the mean. We subtract one standard deviation. Minus another. And another. Okay, what percent is less than 3.74? First off, we find 3.74 on the sketch. And we go 1, 2 standard deviations over. Based off of these 68, 95, 99.7, we will there is 5% outside of -2 standard deviation.
Flacco, put him in the dirt.
Therefore, 2.5% is lower than 3.74. What percent of the scores are between 5.29 and 9.94? Okay, so here is 5.29 and here is 9.94.
And I'm a lady killer. If I want her, I'm a stealer.
Okay. This is one standard deviation away from the mean. This is 2. So 68% between these two. Plus another 13 right there. Equals 81.5%. And 9.94.
Next, we're going to do the standard normal distribution. And the standard normal distribution is the normal distribution with a mean of 0 and standard deviation of 1. If a variable x has any normal distribution and mean, standard deviation, with the mean u, standard deviation o, standardized value z equals x minus u over o, has the normal distribution. Standard normal table is table A, the table of areas under the standard normal curve. Table entry for even values z is under the standard normal curve to the left of z. So now we're going to do normal distribution calculations. And how you do that is we can answer a question about areas in any normal distribution by standardizing and using table A or technology. And there's 4 steps to this called the 4-step process. Number 1 is state, and then that is you stating the distribution and values of interest. Number 2, plan and draw a normal, which you draw a normal curve with all the areas of interest shaded, meaning the mean, standard deviation, and that's it. And then number 3 is do, so you perform the calculations, complete a z-score from table A. And number 4 is conclude, which you answer the problem in context of the problem.
So on our first example is, on the driving range, Tiger Woods practices swing with a particular club by hitting many balls. When Tiger Woods hits his driver, the distance the ball travels follows a normal distribution with a mean of 304 and a standard deviation of 8 yards. What percent of Tiger's drives travel at least 290 yards? So we want and we state our mean is 304, standard deviation is 8. Then we draw our standard normal curve with greater than 290 yards. And then we will do z-score, which is z equals x minus the mean over the standard deviation. And that equals negative 1.75. Then you go to table A, equals 0.0401. And since it is greater than, you have to subtract 1 minus 0.0401 equals 0.9599. So approximately 96% of Tiger's drives are greater than 300 or 290 yards.
Okay, working backwards. State the distribution. Find the z-score. Answer the problem. Okay, this problem has a z-score of negative 0.67 and a mean of 170 with a standard deviation of 30. We're trying to find x. First we multiply both sides by 30, which equals something. And then we add 170 to both sides. Which equals 149.9.
Like I've been ballin' 'cause I'm really ballin'.